Hey guys, this is test 51 game 2. This is the hotel suites game. It's an ordering game. We know this because they say the suites are ranked from most to least, from first to sixth. So I wrote down more on the left, less on the right to indicate that we're anchoring ourselves with more money on the left. So I've laid out some rules here. I'll explain each of those. They tell us that H is more expensive than L, so I put down H-L. Next they say that if G is more than H, then neither K nor L is more than J, and since there are no ties and nothing is simultaneous, that means that when G is before H, then J is more than both K and L. Then they say, we could have done the contrapositive here. It would be really messy to do so, but we actually don't need to because they cover the reverse, the other way things could go on the bottom diagram if H is more than G. Now we know that either J is more than H or H is more than G, so we don't need to actually worry about contrapositives here. Every single valid scenario will fall into either the top possibility with G before H or the bottom possibility with H before J. Now, when H is more than J, we know that neither J nor L is more than K, and since there are no ties, that means they must be less than K, so K is before them. Now, the final rule is a little bit tricky. You may never have seen any rule like this before. Don't worry, I'm going to explain all of that. They say if F is more than J, meaning if we had F was more than G, if we had F before G, then we could not have F before H, meaning that F would have to go after H, in other words, H before F. Then they say, no, or else F is more than H. So if F was more than H, then we know that F could not be before G, meaning that F would have to be after G, or in other words, G before F. So this lays out two different possibilities regarding the HFG ordering. Either we have H before F before G, or G before F before H. This is all a very fancy way of simply saying that F cannot be in the middle F has to be in the middle between H and G. So let's start combining some stuff here. If we're in the world of the top possibility, we have, J before both K and L. Now, when that happens, of course, H is before L as always due to the first rule of the game, and G is before H in this world as well. So when G is before H, you got to have F between them, meaning we've got G before F before H. So that's one major possibility for the game, and you'll notice that this covers every single variable, all 6 of them. Alternatively, if we're in the bottom possibility with H before G, that means, of course, we have K before both J and L. And when that happens, of course, H is before L as always. And now H is before G, meaning we've got the general ordering H, F, G. So I'm going to continue that going forward. And this right here is all 6 of our variables. So these two diagrams are our two major possibilities for the game. Every single valid scenario will fall within one of our two major possibilities, and this right here is our initial setup for the game. Now, question number 6 is a typical orientation question. You could just take one rule at a time and apply that rule to all 5 choices. So I'm going to look for H before L. Scanning through the choices, looking for violations, we see that choice E violates this, having L before H. Therefore, it can be eliminated. The others are all good on that issue. Next, we could look for these orderings, HFG or GFH. F has to be between H and G. It cannot be before both of them, cannot be after both of them. So A is good on that, B is good on that, C is good on that, but D has F last, meaning that it is after both G and H, which is unacceptable, so for that reason, D is gone. Next, we could look for these two conditionals. So when G is before H, J is before both K and L. So where do we have G before H in remaining choices? Choice A we do. We have G before H there. Do we have J before both K and L? No, we do not. We have J in the middle of them. That's unacceptable. Therefore, A is gone. B and C both have H before G, so I'll use the second one now. If H is before G, then K is before both J and L. So in B, we have H before G, and we have K before J and L, so B is good on this issue. However, C is not. In C, we have H before G, yet we have K in the middle of J and L. That's unacceptable. Therefore, C is gone, leaving B for number 6. Next, number 7. If G was the second most expensive suite, So bottom diagram, that's not happening, of course. G is after both F and H, so the earliest G could ever be is perhaps third. So bottom diagrams are relevant. We're using the top one here. If G was second, that means that we've got to have someone else coming before G and everyone else coming afterwards. So the only one that, could come before G and be first would be J. We could have J first, then have, G second, and everyone else coming afterwards. I'm going to get rid of J over here. K is basically anywhere after J, so K could be anywhere from, second all the way through the end, perhaps. So G second, everyone else is coming later. So I could actually move this line and put it after G, since G is second. So J is 1, G is 2, K is anywhere 3 through 6. So what could be true? H more than F? No, we got F before H, therefore A is gone. Next, B, H before G? No, we got G before H, therefore B is gone. C, K before F? Yeah, K is anywhere 3 through 6. K could even be right here between G and F. That's possible. Therefore, C is our answer for 7. I will go through the rest, though. K before J? No, J's first. Nobody's before J. Then looking at E, L before F? No, F is clearly before L, therefore E is gone, leaving C. Next, number 8. What cannot be the most expensive? So the variable that cannot be most expensive always has to have something before it coming earlier in both diagrams. So let's just run through the choices. Could F ever be most expensive, meaning number 1 all the way on the left? Well, no, it actually couldn't, because in the bottom diagram, F is after H. In the top diagram, F is after G, because of course F is always in between H and G no matter what, so it's never first and it's never last. Therefore, A, F is our answer to number 8. And then if you look through the others, of course, G could be first in the top diagram, so that's gone. H could be first in the bottom diagram, so that's gone. J could be first in the top diagram. It's only, got to be before K and L, but could be anywhere early for all we know. D's gone. And then E, K, of course, K is after J in the top diagram, so that cannot be first, leaving F. Next, number 9, if L was before F. That's never happening in the top diagram where F is before L, therefore the bottom one is relevant here. And I'm going to basically want to link together L and F a bit. So I'm just going to take L, move it over here, so I can link it to F and link it to H, for example, and link it to K, so things change just a little bit. What could be true? Could F go before H? No, we're only in the bottom diagram here where H is before F, therefore A is gone. Could F go before K? No, K is before L before F, therefore B is gone. Could G go before H? No, that was the top diagram, which we've crossed off. In the bottom diagram, H is before G, therefore C is gone. Looking at D, G before J, yeah, those guys are still ambiguous. Therefore, yeah, G before J could occur. D is our answer. I will look at E, though. L before K. No, we got K directly before L right now, so E's gone, leaving D. Next, number 10, if H was before J and was less than K. So I'm going to just basically draw a little branch between H and J here. H is before J, but less than K. Turns out that actually wouldn't work in this diagram. There's no way for H to be before J but after K due to the fact that J is before K itself. So top diagram ends up being irrelevant altogether. The bottom diagram is what we're going to use here. So if we put H before J but less than K, we're actually just basically going to take K and move it a little bit more to the left. So I'm going to put K is before H and H is before J. So I'm going to put a branch between H and J. So H is before J, H is before L, and then those are both open-ended. So it's like K is 1, H is 2, and then J, L, F, G are basically fighting it out for 3, 4, 5, 6. So what could be true? F more than H? No, we're in the bottom diagram where H is before F, therefore A is gone. G before F? No, F is before G here, B is gone. G before H? No, H is before G here, so C is gone. J before L? Yeah, they're ambiguous. That could happen. Therefore, D is our answer. I will look at E, though. L before K? No, we got K before L specifically. Therefore, E is gone, leaving D.